Good evening, everybody. Myself, Acharya Vishvendra. Today, I'll discuss a problem based on dipoles. So, here is x-axis, y-axis. A dipole is placed at the origin, so the dipole moment is along x-axis, and we take a point P dash, which is at an angle theta with the x-axis. Now, the question is, we need to find theta for which electric field is along y-axis. So, the concept here is we break dipole moment into two parts. One is along this line P dash, and another is perpendicular to this. So here we have P cos theta. So the electric field will be like this, and for corresponding to this dipole, electric field will be like this. So we take the components and take the components along x-axis. So here the component is E1 cos theta, and here the component will be E2 cos 90 minus theta. So if we want electric field to be along y-axis, then this part should be equal to this, so that x part gets cancelled out and electric field is over y-axis. So we'll use this concept to solve this question. So we can say that E1 cos theta is equals to E2 cos 90 minus theta. So E1 will be 2 kp cos theta by r cube, because it's along the axial position, into cos theta, and that will be kp sin theta by r cube into sin theta. So from here we get 2 cos square theta is sin square theta, which gives tan square theta is 2, which gives tan theta is root 2, which gives theta is equals to tan root 2. So the angular position at which electric field is along y-axis is given by tan inverse of root 2. So you can use it as a direct result that at tan inverse root 2, electric field is perpendicular to the dipole moment. Next we have direction of electric field at a certain point, let's say 0 0 z. So we can say that 0 0 z will lie on z axis. So it will be equatorial position for the dipole, and at equatorial position electric field is opposite to the dipole moment. So it will be like this, and along minus of x-axis we can say. Now is another point that actual value of electric field. So we use the concept that it's kp by r cube. It's opposite to the dipole moment, so we can write minus kp by z cube. Next, here is angle between E1 and E2. So here is another dipole, and there are many points given over here. So here is the dipole, and it's like this. So direction of electric field here will be like this along x-axis. On y-axis it will be on equatorial position, so field will be opposite to dipole moment. On z-axis also field will be opposite to the dipole moment. Now if we analyze the vectors, we can say that angle between E1 and E2 is 180 degree, as the vectors are opposite to each other. Then between E1 and E3, E1 is here, E3 is here, they are also anti-parallel, so angle here is also 180 degree. Then between E2 and E3, so we can say that E2 and E3 are parallel to each other, so angle here is 0. So this is what we can analyze. Now there is one more thing, as you must have seen that when we analyze a particular problem, there are three dimensions of concern. The first is information, second is the process, and third is energy or the emotion. Process involves thinking, pattern extraction, and solution designing, and energy corresponds to the negative vibes, because when you start working on a certain problem, then the first thing that you need to have is to focus on the present and to not get deviated by the negative emotions, by the anxiety, depression, low feelings, etc., hurry, etc. So if you analyze something, take the complete perspective from all the points, so that you are able to develop yourself as a good problem solver and fetch good rank in JEE NEET. Thank you and have a nice day.